Let's go ahead and get started with the silver nitrate bath. This is one of the most important parts of your kind of chemistry collection. It's also one of the easiest to mix. So, silver nitrate bath has two ingredients: silver nitrate crystals and distilled water. Very simple to mix. Generally speaking, people use a 9% solution of silver nitrate for their silver baths. That means that essentially the mass of the silver nitrate should be 9% of the mass of the water in the solution. So if you're going to mix 1 liter of silver nitrate solution at 9%, you should put 90 grams of silver in it. Today I'm just going to mix probably 200 milliliters, so I'll go ahead and put in 18 grams of silver nitrate crystals. Now, silver nitrate crystals are something that you can make yourself, but you probably don't want to. It's a very dangerous and somewhat difficult process, so it's a lot easier to just buy silver nitrate crystals from your wet plate supplier of choice. Personally, I usually buy my silver from Boston & Sullivan. It's fairly reasonably priced, and if you're willing to wait a while, they do usually have sales at least every couple months. So a lot of times you can score their silver nitrate, say between 5 and 15% off the usual price. So silver nitrate crystals, they're going to come in a plastic bottle. You just want to make sure to keep that nice and tightly sealed because, of course, the crystals can stain, and they can also cause damage to your eyes and other body parts if they happen to be ingested. So just keep them nice and tightly sealed when not in use. The other ingredient in the silver bath is water. You're going to want to use distilled water. Now, there are some chemicals for wet plate that you can mix with distilled water, and there are some that you can mix with tap water. However, I recommend just using distilled water for everything. This water, I think, cost me maybe 94 cents at Walmart. It's not expensive, and it's just not worth it, in my opinion, to risk finding out that, any kind of mineral or contaminant in your tap water is causing issues with your wet plate chemistry. Just use distilled water anytime you're mixing anything, and you'll know you're safe. So, let's go ahead and get started here. I've got a small digital scale here. This is, I think, like $15 or $20 on Amazon. It's not a super sophisticated scale. I think it's accurate to about 1/10 of a gram, which is plenty for our purposes. I'm going to go ahead and set a beaker on it. So you don't necessarily need, this kind of official looking labware to mix wet plate chemistry. However, labware exists for a reason. If you're going to be doing this kind of work, it tends to make it a little bit easier and more convenient. So I recommend picking up some basics just to make your life easier. While you could do this mixing in a jar or a large glass or bowl, a beaker is pretty well suited to the purpose. This is a 500 milliliter beaker, and I'm just going to put it on my scale and zero it out. So we're going to make 200 milliliters of silver bath, so I'm going to need 18 grams of silver. Before I open this, do note that I've got my gloves on, I've got my safety glasses on, nice and tight against my face. I'm just making sure that no silver nitrate gets into my eyes, and I'm keeping it off my hands, less so for safety reasons and more so for just not staining my hands reasons. So I'm just going to go ahead and open up the container and start measuring out my silver nitrate. I've got this little double-ended spoon/spade for measuring out powder chemicals. You can buy a 10-pack of these for very cheap on Amazon. It's just a helpful little thing to have. Makes your life a little bit easier when you're trying to measure out very small amounts of powders. So let's go ahead and measure out 18 grams of silver nitrate. at 15.1, 16.5, 17.0. As I approach the mark, I start to be a little bit more careful. So I went over, I got 18.5 grams in here. I'm just gonna pull a tiny little bit out with my spoon. That gets me to 18.3, 18.2. Back down to 17.8, so we need just a tiny amount. Sometimes after adding just the most minute amounts, you need to give the scale a little tap to get it to remeasure. Still at 17.9. There we have 18.0 grams. So, we got our silver nitrate crystals in the beaker. Now I just got to measure out 200 milliliters of distilled water. So for this, I'm going to use a graduated cylinder. A graduated cylinder is kind of the one thing that you really are going to want to have for preparing your chemistry and wet plate. It's by far the easiest way to accurately measure out liquids. So this one is a pretty tall cylinder. This is a 500 milliliter. Most of the reason that I have a cylinder this big is for silver bath maintenance, which is something that I'll touch on in a later video. If you're mixing small amounts of chemistry, a 100 milliliter cylinder is a really useful thing to have. But for instance, right now, when I'm wanting to measure out 200 milliliters, it's nice to have a cylinder this big so I can do it all in one go. So what I usually do is get close to the mark, pouring straight from this jug. And then I have this little squirt bottle, also full of distilled water. And I'm just going to use this to get myself all the way up to that 200 milliliter mark. And at the very end here, I'm going to get down and take a look at this. I want to get that meniscus of the water straddling the 200 milliliter line. And once I get that, I'm happy. So now, all we gotta do is mix the two together. I'm gonna go ahead and take the silver nitrate crystals, pour the water in carefully, make sure not to splash any out. And I'm just gonna take a glass stirring rod and stir in the crystals. You want to get the crystals completely mixed into the water. Now, as you do this mixing, what you should end up with is a perfectly clear silver nitrate solution. If the water turns cloudy, it means that there is some kind of a contaminant in the bath that the silver nitrate is reacting with. If you find yourself with cloudy water, with a cloudy solution, the problem could be that your distilled water was not as pure as you thought it was, or it could be, say, a dirty mixing vessel. So if it does turn cloudy, you're gonna need to skip straight to silver bath maintenance. Don't try to use cloudy silver bath. This batch, however, is shaping up nicely. I like to just get down close to the bottom here, make sure I've got all the crystals. There are a few hanging around there in the middle. And there we go. I also like to keep paper towels handy anytime I'm working with chemistry. Lets me just keep things neat and tidy and clean up quickly if I happen to have a spill. So here, I've got just about 200 milliliters of silver nitrate bath. This is a nice clear liquid. This should sensitize my plates just fine. Now there is one final step that is typically recommended here, which is to iodize the bath. That is to say, to get some silver iodide kind of floating around in it. So what is typically recommended at this point, if you have a brand new silver bath, is to take it and pour a plate with collodion and leave it in the bath overnight to allow some of that silver iodide to kind of diffuse out through the silver bath. That being said, some people have reported that step is not necessarily required. Your first few plates may just need a little bit longer sensitizing time if you don't iodize the bath beforehand. If you decide to iodize your bath, it is absolutely critical that you use a glass plate to do it with. A very common mistake is people see that they're supposed to leave a plate in the bath overnight, and they pour an aluminum plate and leave it in the bath. The aluminum, if it's left in your silver bath for an extended period of time, can actually leach silver out of the solution. So if you iodize the silver bath, do it with a glass plate poured with collodion. Another option, and the one that I actually opted for when I first got started, is you can just buy your silver bath pre-mixed from UV Photographics, and they will actually iodize it for you ahead of time. It's honestly not a huge deal, but if you're just getting started, it's one less thing you have to figure out. So for me, it was worth the extra to have it pre-mixed. Now, if you already have an existing silver bath, for instance, I have about 250 milliliters here, you don't have to iodize anything that you're adding to it. As long as you have a decent amount of existing, already iodized silver bath, you can top it off with new, fresh silver bath, and everything will work out just fine. Now, a quick note on containers. So this is a Nalgene plastic sample bottle. This is my favorite type of bottle to store silver bath in. You don't have to use these bottles. Pretty much any plastic container with a good tight seal on it is going to be fine. But these, they're just the right combination of sturdy. They have nice markings on them. Yeah, and as you can see, this one is super heavily stained by the silver nitrate, so do keep that in mind. The silver nitrate stains everything that it gets on, but your bottles like this, you can always clean the stains off of. This is not a material that permanently stains. So that should be everything you need to know about mixing your silver nitrate bath. Now let's go ahead and move on to the next chemical, the developer. All right, I know I said developer was coming next, but I forgot I need to talk about collodion first. So needless to say, if you want to do collodion photography, you're going to need some collodion. Now there are 3 ways that you can buy and or mix collodion. The hard way is you can buy USP collodion, which you can buy from just about any chemistry supplier. You can buy additional alcohol and ether, as well as the metal salts needed, and you can mix them all together, create your own collodion essentially from scratch. In my opinion, mixing your own collodion that way is very rarely worth it. I have done it, and the amount of money that I saved was essentially negligible, and it is a huge hassle between buying all the supplies, cracking open a fresh bottle of ether in your home. It's just not a super enjoyable experience. Personally, my recommendation is start with pre-mixed collodion. At some point, maybe mix a batch yourself just to get it out of your system, to demonstrate to yourself that you can figure out how to do it, and then go on the rest of your life using pre-mixed. Unless you shoot in some serious volume, you're just not really going to save yourself any money by mixing your own collodion. Now, an in-between option is that you can buy collodion as a 2-part mix, where you get in one bottle the USP collodion, which is kind of the generic product that you would get from any supplier. And in a second bottle, you get what's called an iodizer or a bromoiodizer. So this is a 2-part mix from Boston & Sullivan for Old Workhorse, which is kind of a really classic collodion recipe. There are a great many different collodion recipes that you can use for different purposes. In reality, I think the differences between them are not as pronounced as some people think. But Old Workhorse is a very popular, kind of almost default variety. So Bostic & Sullivan sells it both fully premixed and as this two-part mix. Now, why would you buy a two-part mix over just buying it premixed? The reason is both of these bottles will keep for a very long time. But when they are mixed together, the collodion starts to age. And within a month, it will start to noticeably change color from the kind of straw yellow that you see here of freshly mixed collodion. And it will turn more and more red. And as it starts to get darker and more red, two things happen. One, it gets slower by potentially several stops over the course of its life. So very old collodion just takes a ton of light to work with. The other thing that happens is that it gets weak. So sufficiently old collodion will actually dissolve away when you varnish your plate, which is not something you want to experience because everything will seem fine all the way up to the very last step, and then you pour the varnish on and poof, the alcohol in the varnish just erases your image. So ideally you want your collodion somewhat fresh. That's where the two-part mixes are really nice. The individual components will keep for a very long time, and then you can mix it and have fresh collodion. Now, Old Workhorse is not a very fast collodion formula. If you're doing, a lot of still life or landscape work, that doesn't necessarily matter. If you're doing portraiture, I wouldn't especially recommend Old Workhorse. You can use it, especially if you are, say, using a head brace and just doing longer exposures, but it's not a super popular formula for portraits. For that reason, I don't generally buy collodion from Bostic & Sullivan because, at least as far as I know, they only sell Old Workhorse. The reason that I have this two-part mix from them is because Old Workhorse is really good at mixing with silane, which makes it adhere really well to glass. So I'm going to be using this mix for hopefully some dry collodion negatives in the future, but that is not really relevant to us right in this moment. Now, by far the easiest way to get started is just straight up pre-mixed collodion. So I wish I had one of the original bottles to show you because this is obviously not how it came in the mail. But this is UVPX from UV Photographics. You buy this pre-mixed, and this is my all-time favorite collodion recipe. UVPX is two very good things. One, it is fast, like really fast. It's one of the fastest collodion recipes you will ever use. And two, what makes it very unique is it is extremely long-lived. So UVPX will not stay super fast forever, but it will stay usable for a very long time. I have used 10-month-old UVPX with nothing added to it to stabilize it over all that time. And I would say it was about a stop and a half slower than when I first bought it about 10 months earlier. Now, if you're used to film photography, that may not sound super impressive, but for a collodion to last that long mixed is extremely unusual. Typically, the types of collodions that I mix fresh, I try to use them within, say, a month tops. If I haven't used them by then, usually I'll dump them into kind of an old collodion bottle that I just use for landscapes, and I'll mix fresh collodion for portraits or whatever I'm shooting. UV Photographics also makes some two-part mixes for some very fast collodions. UVP3 is my favorite mix of theirs in the two-part variety. But UVPX is a great kind of general purpose collodion. Highly recommend picking it up as a starter collodion. The only thing is make sure you don't buy too much because you may be like me and just drastically overestimate how much you're going to need and find yourself with a bunch of it left over 10 months later, which is okay, it still works, but it's going to be starting to slow down by that point. And so in general, I just recommend buying small quantities to begin with so you can get a feel for how much you're going to use and what things you're going to like to use the most. and that is, very briefly, my collodion recommendations. A word on containment. So you may notice that I have this in a media bottle. This is a type of storage bottle. I think you may see it called a media bottle. Pretty sure there's another common name for it, but it's escaping me off the top of my head. This is great for storing all kinds of potentially fumey and generally nasty chemicals. So it's made out of pretty tough glass. It's not going to break easily. It has a nice tight fitting cap on the top, and it also has this little drip ring on the top of the interior that helps you pour without dripping afterwards. So I actually like to store my collodion in these glass media bottles, and I also pour out of and then back into the same bottle, which is something that we'll talk a little bit more about once we get into actually making plates. I have bought both these, the nice Pyrex media bottles. I've also bought cheaper media bottles. The Pyrex ones are more expensive, but after buying a couple of them, I think I'm going to keep buying them because they just come with much better fitting drip rings and the quality is just a little bit nicer. So that's collodion. Now let's move on to developer. Okay, now it's time to mix some developer. Now before we get started here, I should note that you can buy pre-made developer concentrate, in which case all you have to do is mix that concentrate with distilled water to get working wet plate developer. There's absolutely no shame in using that to start out with. I actually probably used Bostic & Sullivan's pre-mixed developer concentrate for at least the first 2 or 3 months that I shot wet plate. The reason that I moved on to mixing my own developer is because, first of all, most developer recipes are faster than the concentrate, at least that B&S sells. I've never used UV Photographics' developer, but I know the Bostic & Sullivan developer is relatively slow, which at first I didn't realize that the developer could actually affect the speed of your plates. But essentially the B&S developer, it's not very aggressive, which makes a lot of sense if you're just getting started because it gives you more leeway when you're developing to avoid ruining your plate. But as you move on and you want to, say, maybe shoot portraits with shorter exposure times or using strobes, it's really useful to be able to mix a more aggressive developer on your own. The other thing is that mixing your own developer gives you control over the process. If you are working in hot environments, you can make the developer less aggressive to account for the heat. If you find that the developer isn't flowing across your plate evenly enough, you can add a little bit more alcohol to help it flow better. It is the one part of the wet plate process that you may actually want to do some tweaking just to get things working, ideally for your use case. So developer concentrate, not a bad thing to start with, but I'm going to show you how to mix your own. So the recipe that I'm going to be mixing here is my own personal favorite. It's one I picked up from the internet. It is a little bit more complicated than some of the more standard recipes. So what I'm going to do is in the description of this video, I'm just going to dump all of the recipes that I've collected over the last year. You can try them all out for yourselves. In my opinion, this is a really good, all general purpose positive developer. This gives me nice fast plates, but I've found that it's well enough restrained that it's very easy to develop without the plate getting away from me and causing overdevelopment issues. So let's go ahead and get started. I'm not going to mix a whole lot today. I'm just going to mix 1/4 of my usual recipe, which I have written down here. So let's go ahead and start with the 3 solid ingredients. So those are ferrous sulfate, copper sulfate, and potassium nitrate. I believe that I bought all 3 of those from Bostic & Sullivan. You don't have to buy these from a wet plate supplier. You could probably find these on eBay or from any general chemistry supplier. for me, it's just a matter of I'm usually shopping at B&S for some photography related things anyways, so I may as well grab my developer chemicals while I'm at it. So not necessary, but they stock it. It all works perfectly well. So let's go ahead and measure this out. So I'm doing 1/4 of this recipe, so I'm going to get 2.5 grams of ferrous sulfate. Now, ferrous sulfate tends to clump up in the jar, so I like to break it up a little bit with the spoon just to make my life a little bit easier when I'm mixing it later on. That's 1.1 grams. It's 1.5. 2.3. 2.4, still 2.4. Measuring out 1/10 of a gram can be a little bit tricky. And that gets me to 2.5. Okay, now I'm going to do something that is a little bit reckless, but will save me some containers to wash later. I'm just going to wipe off this spoon, and I'm going to use the same container to measure out all of the powdered chemicals. So I'm just going to re-zero my scale, and I'm going to start over with the second ingredient, copper sulfate, also from Boston Sullivan. I'm just going to go ahead and measure out 2.5 grams of this as well. Copper sulfate is this really brilliant blue powder. It gives a really interesting look to the developer, as well as allegedly brighter highlights in the developed images. So I need to be a little bit careful here, since obviously I can't remove copper sulfate from this beaker because it's mixing in with the ferrous sulfate that's already in there. I'm at 2.3 grams, 2.4. Just being very careful here. Still 2.4. 2.4, 2.5 grams. So I'm going to go ahead and zero out this scale one more time, wipe off my spoon, and move on to my third ingredient, potassium nitrate. And the potassium nitrate is what, in my opinion, really makes this recipe great, because it helps to restrain the development and keep you from really overdeveloping your plates too easily. So I'm going to need 1 gram of potassium nitrate. Now this really likes to clump up, so I'm just going to kind of crush it down a little bit here. Try to get some as powdery as I can. I just want 1 single gram here. That's 0.2 grams. 0.3. Let's get a little bit bigger spoonful. 0.8. 0.9. Oh, back down to 0.8. We got a misread. .0 grams. Okay, that is all of the solid ingredients of the developer. Now we have 3 liquid ingredients left: water, acetic acid, and alcohol. The water is obviously just holding everything together. The acetic acid is going to be also a restrainer, and the alcohol helps the developer to kind of spread evenly across the surface of the plate when we pour it. So before I go any further, I'm just going to kind of smash some of the clumpier bits of ferrous sulfate and potassium nitrate in the bottom of this beaker. Just make sure everything mixes as easily as possible when we move on to the next step. Okay, now I like to go ahead and add the water first so we can get everything mixing. So I'm going to use 1/4, so I'm going to be using 125 milliliters of water here. Same thing as before, I'm going to fill most of the way from the jug. I actually went a hair over, so I'm just going to pour some of this out. Well, I've got nowhere to pour it. So, actually, here's what I can do. Pour some out here. And that's actually dead on. So I'll go ahead and pour that into my beaker. Then we'll just pour the excess in here and set it aside, because we're going to be using the small cylinder next. Okay, so you can see now the developer starting to come out. It's kind of this bright blue color to begin with. That's going to change when we add the acetic acid. The next thing I'm going to add is the alcohol. So, a word about alcohol. Alcohol is a lot like water when it comes to wet plate, in that there are a lot of places that you can get away with alcohol that's not pure. Denatured alcohol is easier to get your hands on. For instance, you can buy it very easily on Amazon as fireplace fuel. Denatured alcohol is, in theory, fine for developers, for varnishes, potentially even for collodion. The problem with it, though, is that you don't really know what they use to denature the alcohol. And to be clear, denatured alcohol is just pure grain alcohol that has had some kind of bitterant or other chemical added to it to make it unsuitable for drinking. Right? They want it to be an alcohol that you don't have to worry about your kids getting into if you keep it in the house. So ideally, to avoid any potential issues with unknown contaminants in the denatured alcohol, I just try to use pure grain alcohol anytime that I'm mixing chemistry. I buy this off of eBay. I think it's marketed as perfumer's alcohol. If you're lucky and you live in a state where you can buy, I think, 190 proof Everclear, you can just get it from your local liquor store. But if not, you may have to buy it online. Boston Sullivan also sells pure ethanol. I'm sure there's all kinds of other places you can buy it online, and probably a couple of other brands of spirits that sell pure ethanol. So I'm going to use 1/4 of what this recipe calls for. So I'm going to put in about 5 milliliters of alcohol. And I just realized that the minimum that this cylinder can measure is 10 milliliters. So I'm going to be eyeballing this a little bit. That's about halfway to the 10 milliliter mark, so that should be fine. Then I'm just going to pour that right on into the beaker. Mix a little more. I've still got some solids in there from the powder ingredients. I just keep mixing this as I go along, get a little bit closer to fully mixed every time. Crush some of the bigger crystals of copper sulfate. Keep mixing. Now comes the nasty part. It's time to add the acetic acid. So, this is glacial acetic acid. The reason glacial acetic acid is called glacial is because it has a weirdly high freezing point. I think this freezes at something around like 60 Fahrenheit or just some completely ridiculous temperature. So I actually ordered my first bottle of pure acetic acid. I had it delivered to my apartment in Los Angeles. I think it was in the winter at least, but I came home from work one day. Nice new bottle from Boston & Sullivan was there. Took it inside, opened up the box, and my bottle of glacial acetic acid was almost completely frozen through. So if you order this during the winter time, you may find it frozen on your doorstep. It's not a big deal. Just bring it inside where it's warmer. Give it some time to thaw out. This is a very strong acid. So there's two things to watch out for here. Well, three, I guess, right? First of all is don't get it on you because it can be painful. Always wear gloves, safety glasses while handling it. Second is it has a very strong fumes to it. I do not like to crack open a bottle of this stuff without a respirator on, which is why I have my respirator here, and I'm gonna put it on while I measure out my acetic acid. The other thing is that it will stain clothing. I've gotten this on my pants before and it just left kind of it essentially bleached a part of the pants in a splotchy way that has never come out. So avoid getting this on you, avoid getting it on clothing. Just try to keep it either in its bottle or in whatever container you're mixing it with. So I only need 3/4 of a milliliter of acetic acid for the volume that I am mixing here. So what I like to use for these kinds of very small volumes is this. This is a disposable, very small plastic pipette. This is great for measuring out very small amounts of liquid. This has measurements on it to the nearest 0.5 milliliters, from 1/2 milliliter all the way up to 3 milliliters. So if you're in that range where you don't have small enough increments on your graduated cylinder to measure a liquid, these things are really handy. Plus, if I'm dealing with something like acetic acid, it's really nice to be able to just pop this in, pull a little bit out, and be done. I don't like keeping this bottle open and pouring it back and forth from a graduated cylinder, trying to get just the right amount out, because that makes my entire apartment just reek of acetic acid. So I'm going to throw this respirator on. I'm going to measure out my 3/4 of a milliliter, and I'm going to put it in the beaker. I'm going to have to take my safety glasses off to get this on. Gonna give it a second to clear. All right, and now it still smells a little bit like vinegar here, but the fumes are not oppressive anymore. There we go. I've got all the solid and liquid ingredients mixed nicely together. That is an almost ready to use developer. The only thing left to do is I like to filter this through filter paper before using it. So, if you've never used filter paper before, the way that I have learned to fold this is to just fold it in 4 folds on each side, and every time you fold, you want to fold right down the middle of 2 of the existing fold lines. After folding that first side, I'll flip it over. I'm going to fold it 4 more times, still subdividing in between 2 lines every time I fold. Sorry for the break there. Someone forgot to change memory cards, and that someone is me. So just to take a step back, I have now fully folded this filter paper, and I also wet it a little bit with some distilled water. And after fully folding it, it becomes very easy to fold it into this kind of accordion cone shape. And then I can just set it right into my funnel in the ring stand. Now, the container that I'm going to be filtering my developer into is this steel thermos container. You don't have to use a container like this for developer. Any old normal plastic or glass bottle should work fine. The reason that I like to use these containers is because I typically shoot outdoors in some very warm environments, which you can adapt your developer for, but I find it easier just to mix the same developer and keep it in an insulated container. That way my developer is always nice and cool when I pour it out and go to use it. Shooting multiple hours in Florida in August, I've never had a problem with my developer overheating when I keep it in this nice insulated bottle. So all we're going to do is pour the developer from the beaker we mixed it in into the filter paper in this funnel. And developer can take a little while to filter, so I'm not going to sit around and wait for this whole thing, but that is the entire process. After that, I'm just going to wash my containers, and then we'll move on to the next segment, which is going to be the very simple task of mixing fixer. All right, while that developer is still filtering off to the side, I'm going to go ahead and mix up the fixer that I'll be using tomorrow. So, whatever type of fixer you use, ammonium thiosulfate, sodium thiosulfate, or even cyanide, it's usually pretty simple to mix. It's generally just going to be a matter of taking your preferred fixing chemical and mixing it with water to the appropriate concentration. So I have here sodium thiosulfate, or hypo. This is just a tub of it that I bought from Boston & Sullivan. You can also buy it from Photographer's Formulary, probably a million other sources. This stuff, I personally don't use it for wet plate. I use this for daguerreotypes and for fixing prints, but you can use it for wet plate. It just takes longer to fix and longer to rinse. My personal favorite for fixing wet plates is ammonium thiosulfate, or rapid fix. So there are multiple different ways you can obtain this. Ilford makes a rapid fix chemical that they sell for fixing film. Ilford Rapid Fix will work fine for wet plate, but you have to make sure that you give it a good long rinse time, because Rapid Fix includes apparently some kind of acidic additives that are helpful for film but detrimental to wet plate. So I recommend buying your ammonium thiosulfate or Rapid Fix from either Boston & Sullivan or Photographer's Formulary, because they both sell the pure chemical with no additives that could be harmful to your plates, which means that you get relatively quick rinse times. In theory, you could use as little as 10 to 15 minutes of rinsing for a plate fixed with ammonium thiosulfate, but I don't like to risk it. I generally go for 25 to 30 minutes anyways at a minimum. You cannot overwash a plate, but you can definitely underwash it. So in my opinion, it's usually just better to be safe. So this is from Photographer's Formulary. The ammonium thiosulfate from Photographer's Formulary costs less, and as far as I've been able to tell, it's exactly the same chemical and exactly the same concentration as BNS sells, so I just buy it from Photographer's Formulary. The amount of fixer that I always use to fill my Lund Photographics 4x5 tank is 360 milliliters, and I mix this at a 1:3 ratio with distilled water. So that means I'm going to need 90 milliliters of fixer concentrate, 270 milliliters of water, for a total of 360 milliliters of fixer. So what I usually do is I just take my big graduated cylinder, I measure out my 90 milliliters of fixer concentrate. This is not the friendliest bottle to pour from. There we go. And then I'm just going to top that up with distilled water to get me to 360 milliliters. I'll get to about 350, pouring directly from the jug. Use my little squirt bottle to get up to 360. And I'm just going to take my glass stirring rod. I'm just going to stir that up until the fixer is good and mixed in. And then finally, I will pour it into my fixer tank. Now you're not going to want to keep the mixed fixer around for too long. It doesn't have the longest shelf life. So personally, I always try to mix fixer immediately before a session, or in this case, the night before if I'm recording a video. And then just use it the day of and use that batch that one time. And as infrequently as I shoot, I usually just buy it by the liter. So that's fixer. That is all there is to that. And that is all the chemistry that we're going to need to mix to get started. I'm going to do one final segment here just to show you what varnish looks like and talk a little bit about how to procure it and how to store it. Let's go to varnish. All right, one last chemical to talk about, and that is varnish. Now there are two basic varieties of varnish traditionally used in wet plate photography. Those are Sandorak varnish and shellac varnish. Sandorak varnish is based on Sandorak resin, which is a tree resin. Shellac varnish, I believe, is based on the secretions of the lac beetle, but I might be mixing that up with with lacquer, so don't quote me on that. Personally, I use Sandorak. I think Sandorak is the most popular varnish. It tends to be viewed as kind of a default in the wet plate community. Personally, it's the only option for me because I don't use animal products, and shellac is some kind of a beetle secretion, so I just stick to my Sandorak. You can also use more modern art varnishes for wet plate. I kind of recommend against it just due to the fact that we don't know how well those varnishes are going to perform over, say, the next 100 to 200 years. Whereas there are now, 150, I want to say, year-old Sandorak varnish plates that are still in perfectly usable condition today in 2020. So Sandorak varnish is affordable, it's easy enough to use, and it has stood the test of time. So is shellac varnish. Either one of them will serve you well. Now, you can buy Sandorak resin in chunks, and you can grind it up and mix it with alcohol and lavender oil and make your own varnish. It's a huge hassle. It takes a ton of filtering. Personally, I just buy pre-made varnish. I've never even attempted to make my own varnish. I really don't think there's any point in doing it. I say just buy your varnish pre-made. If you really want to get into it, you can try making varnish, but there are multiple suppliers that sell it pre-made. I buy mine from Boston & Sullivan. UV Photographic sells it as well. I'm sure there are probably other sellers. I know Gerald Fiegel sells kind of smaller batches of shellac varnish. There are probably more places you can get it from, but it's affordable enough that I just recommend buying it pre-made. Now you can store it in pretty much any kind of container. It's not an especially volatile or dangerous chemical, aside from the fact that it is flammable. There's a lot of alcohol in here, so be careful around open flame, which you may be using while varnishing, so just exercise some caution. Personally, I tend to like pouring this from either a media bottle or an Erlenmeyer flask like this one. If you store it in a flask, you'll have a stopper on top that just pops out and pushes back in. Media bottles with sealed lids are nice. You just want to make sure that it is sealed up good and tight so the alcohol doesn't evaporate out of the varnish while it's sitting on your shelf. Now, unlike Collodion, which I generally pour out of and then back into the same bottle with no ill effects, Varnish, you really want to keep clean when you're pouring on your plates, so you're not going to want to pour the excess varnish from the plate back off into the same bottle after it's picked up gunk from the air from being on your plate. So for that reason, anytime you're varnishing, you're going to want to have at least 2 bottles on hand. One bottle to pour your varnish out of, and a second bottle to pour your varnish back into. That's the excess that's going to flow off of the plate after you've thoroughly coated it. So for me, here I just have this brown amber bottle to collect the drip from the varnish pour. You can also use a media bottle. Generally speaking, the bigger the mouth on the bottle, the better, because it's just going to make it easier to pour off the plate into the bottle. But these work fine. One final note is that a lot of people like to pour varnish actually from test tubes. A small container like that is ideal because before pouring the varnish, you're going to want to heat it up over a heat source, an alcohol lamp in my case. And the more varnish you have in your container, the harder it is to get it warmed up for pouring onto the plate. So if you keep a very small amount of varnish in a test tube prior to pouring, that's very easy to heat up. However, I'm a little bit lazy, so I just keep my varnish in a flask or sometimes in a media bottle, and I pour directly out of that. And with that, I believe we have covered all of the chemistry you're going to need to mix or buy to get started making wet plate photos. So this is going to be the last part of the series that is preparation. The next video you see is going to be about pouring and sensitizing your first plate. There'll be a few more following that, going through the rest of the process. And then after that, it's just all going to be cleanup and maintenance and next steps. So, with all that said, best of luck buying and preparing your chemistry, and until next time.